Hello, everybody. I hope you do manage to get to this last final session. My name is Jakub. My name is Jakub Marchwicki. I am broadcasting you from Poland, from Gdańsk, which is quite far from where the original Codecamp did happen. But yeah, thanks to internet, it's pretty fast. So what we'll be talking about is testing, and especially testing in the microservice environment. And when it comes to testing, people say, yes, there is this test triangle. We have unit tests, we have integration tests, and some UI or very high level test. And this term has been coined years ago, literally years ago. And as our stack evolves, it's getting better and better. Can we evolve the testing triangle? Can we apply something more modern in the approach to testing as our test progresses? Because unfortunately, if we think about distributed systems, and this is pretty much microservices, we are unable to build everything at once. We are unable to assemble everything and like freeze the world to run our tests. Well, we can try that, but it's really cumbersome, it's really hard to do, and it will take ages. So what can we do better? What can we do to improve our testing? And this is what this will be about. So my name is Jakub Marchwicki. As I said, I've already spoken with the guys, so you know a little bit of background. I've joined Hazelcast Cloud, and yes, we are pretty much enabling Hazelcast as an in-memory data grid and more as a platform. So with all the features that are in the enterprise version, but through the cloud, so we can go register and play with it, use it, and pay as you go. And when you build this kind of product, and you think it will be brilliant to be able to run it on AWS and on GCP and this other platform that everybody spells wrongly, which is Azure or I don't know. It's really challenging. You have to encapsulate different things, different dynamics, and you have to really think how you do testing. Otherwise, you end up in a fractional state of not being able to deliver quality software. So when we talk about testing, triangles, this is pretty much the image that we have in mind. And the integration testing is everything that is not unit, not the UI. So all the APIs, databases, contracts with other systems, pretty much everything falls down there. And even though it looks like a tiny thing, it's becoming very, very important. And we'll cover quite a lot about that. Because when we talk about the integration testing, we try to handle two things at the same time, which you probably know from some weird internet memes where things run together weirdly works. But then we have UI testing, so something this what users interact with, what users see, and it's really hard to test, it's really hard to automate, and that's a challenge that we are having as well. And then we can say, well, we are unit testing, and unit testing is individual bits and pieces. So how can we put it all together? So within the Hazelcast Cloud, we are talking with different vendors, and this gets pretty shady because you need to encapsulate different things to be able to test a subset, sometimes test it with isolation, sometimes test it with real user scenarios on the cloud. So think about integration testing, but with database and different database engines, but on a whole different level. And when that's a challenge that you are facing, you cannot just throw a number of people on your application and say, hey, test it. You have to rethink how you build up your test, how you organize this stuff all together to be able to deliver on quality not only on quantity of tests. And that's what I'll be covering. But when it comes to testing, there is one more level which happens when you're in a distributed system. So you're not only building something that runs on the cloud and integrates with the cloud, but your system is composed of multiple different components, so microservices. And yeah, does it impact how we testing? Should it impact? In my opinion, yes, because not only we have to validate that the logic we are implementing is correct, but also we have a number of non-functionals which we haven't thought in the more monolithic word that we have to check. Otherwise, we'll be just blind guys on the production, and that's not something that we can afford. So before we jump into the details, let's imagine we are having a microservice application. This is a very high-level view of a microservice service, well, of a service in a microservice environment. So we have our code running in a framework that always run in a pod on Kubernetes or on EC2 or as a whatever thing on Heroku or whatever cloud vendor. This kind of is isolated, and this piece that is isolated, this one, takes some HTTP requests. Somebody is talking to us, and then we store stuff in the database, and we call out other services, and then we have some logs and monitoring, so some other non-functional requirements which we have to adhere in our world to the production readiness and to be able to know what we are talking about and how things are running. So if we if we look at each and every microservice pretty much from this level of abstractions, that's get pretty easy when it's come to unit testing, because unit testing is our code. We have to verify the logic. We have to get a number of tests that pretty much confirms that what we've been implementing really works. And no further questions. We should just do unit testing. And if somebody says, well, I don't know, well, no, it's like 21st century, it's 2020. You have to test your stuff. The rule of thumb here would be these tests need to be blazing fast. So no IO, no web service, no rest assured in Java, just pure business logic, mocking out everything that's outside our core domain, our core responsibility within a project. Good tip, hint for the day is never trust the test you haven't seen failing, because that will be something that will save us. But that's just unit. That's the boring part of our testing pyramid at the moment. And let's see if we're moving further. And this is our archetype for the microservices. What else do we need to know before we get out of our service to production? So when it comes to microservices, the first and fundamental question is, once I get confirmed that my business logic is working, will my service start? Will it really runs when I go with that to production? And that's not obvious questions. We'll get to that later on. Then, can I deploy? Because being able to deploy, like the service will be starting, is not equivalent to ability to deploy is not equivalent to deploying itself, because what if my deployment changes something that other services who are talking with my service or consuming data that I'm exposing or consuming data that I'm sending out will start failing? So can I deploy? Am I keeping the backwards compatibility with those who are talking with me somewhere there? Then will this deploy? Because it starts, it doesn't break compatibility, but then there is a number of non-functional requirements usually servers do have when it comes to deployment. Say Kubernetes and liveness and readiness check. This is something non-functional that we have to provide within our service, otherwise it won't work. And this is just one among many, many different things that we might have due to compliance or whatever. So that's another question we have to answer ourselves. And then, will it run? Like, will it continue to successfully operate within this environment? And the question is, within the topic of the presentation, is like, would it work? And can we test against these requirements? Can we verify upfront in the design time and the build time that it's working and everything is all right? Not in the runtime when the things just hits the fan and we go out to production, because that's usually too late. So let's get to our microservice architecture archetype. We used to run our code within a framework. It's like no one ever anymore just write vanilla code, whether it's Node.js, whether it's Java, whether it's any other language. We usually employ some framework that helps us to get out to the world with some ideas. In Java, it can be Spring, it can be Javelin, some lightweight frameworks. And Node.js is probably Express.js. There are things in PHP, Golang, and others languages. So we are running our code in context of a framework. And one can say, yeah, sure, that's not a problem. Well, kind of it is, because the framework, the whole idea of a framework, that it delivers us some of the configurations, some of the auto configurations, for example, in Spring, some of the features that we are using heavily and we are depending upon within our code base, within our application. And at some point, we have to test it, whether this still works. We assume that Spring initializes some caches. We assume, for example, that Spring framework, and some of the examples will be from the Spring framework, are using some auto configuration for the JSON mapping, like the new object mapper and so on and so forth. And having that thing misconfigured between our test and the production can lead to just unexpected behavior of runtime failing of some particular messages that we are sending, or some particular payloads that we are sending out. So we have to test it. And for example, we can, within the Spring, we can test it with the JSON test. We have something called JSON test. So it's a Spring annotation that tells us, for this particular test, we will bootstrap the Spring framework together with the minimum configuration that will allow us to use object mapping. So object mapper from Spring framework. Why we want it to be injected before we start testing? You can say, well, that's a pretty easy test, but this test is dependent on some internal configurations that framework provides us, or framework did due to some conventions, so that this timestamp is being deserialized and serialized in this particular way. And these fields are being mapped to a particular fields on my sample bean. So this is snake case. This is camel case, not a snake case, or not neither the kebab case. So this is something that is built internally within the object mapper. And people can say, well, but running Spring, it takes time, and yeah, it's a little bit more. We can just do new object mapper. But the thing we are missing here is that this test will fail because we are running a different configuration than the default Spring, and this default Spring is something that we are using on production, and we want in our task to be as close to production configuration as possible. So this little thing as the just mapping JSON from object to string and back, from text representation to string and back, can lead to some unexpected things, like the serialization of timestamps is one thing. Handling fields like the parsing, whether it's snake case or camel case, handling unknown fields, that's all within the configuration that Spring or the framework provides us. And if we are using that in a production environment, then we should test it. And I put it as a kind of a lightweight integration test. Why lightweight integration? Because I'm not just testing my own code. I'm getting beyond my code and testing my assumptions. I'm getting from assumptions. I'm testing assumptions about things I will be getting from my framework. So we have this basic integration testing. So I'm trying to verify, am I using the framework correctly? Is the configuration properly read? So are the objects serialized and serialized? And does my logic work with all the dependencies being abstracted away? And then people say, hey, it's expensive. It costs time. It costs a lot of time. Yes, it is. It takes more time than just a unit test. But let's be serious. Well, cold start of a unit test takes about 80, 90, 100 milliseconds on my laptop. Obviously, if you're running a suite or already warmed up JVM, that's a little bit different, but like cold start. And then this JSON test cold start takes about 1 second. So it's like 10 times more for the cold start. But to put you in the context, when you are talking about time, do you use Mockito extension or you just wire mocks yourself? Because if you're using Mockito extension, that already takes time. And that pretty much plays you close to initializing the Spring from itself. About 600-800 milliseconds per cold start, test. So yes, there is a price connected related with that, but we have to understand it and understand it better to be able to decide whether we should have more of this kind of test or less, or how we should design them. So why are we even talking about time in terms of in the context of testing? Well, a friend of mine coined a term which he recently shared. It's called testing budget. Imagine that you have a limited budget to run your test. Say 3 seconds, 10 seconds, 30 seconds. I know builds that are taking 20, 40, 50 minutes, a complete build, which constitutes on many, many different tests sometimes. And we have to think which test we are running and when and how many of these we have. And we are thinking about these tests because they can give us confidence that we haven't done anything wrong. So the question is how many of these tests we can fit into this limited time budget. Why are we talking about this time? Why are we talking about this speed? Because like in most of the cases, you can say, oh, Jenkins is running that and, I don't care, I'll just grab a coffee. And this coffee is problematic. And why is it problematic? Because when we wait for the test to finish, and this is not my idea, it's taken from old legacy user experience and cognitive psychology books about response times, there are 3 important limits that we have to understand. And that puts us pretty well in the context of testing. So when the system reacts in less than 100 milliseconds, or approximately 100 milliseconds, we have a feeling that the reaction is instantaneous. So if we run our test, if we in our IDE just run the shortcut to get the test done, to trigger them, and it happens within 100 milliseconds, we have a feeling that it goes pretty fast. If it's that fast, we can, for example, on every button or on every trigger of the test, just run all the unit tests we have in our project. And there can be like 40 of them. They will run it in a few hundred milliseconds at most. That will give us this instantaneous feedback. Why it's important? Because we are still in this context of this particular thing that we are doing, this particular scenario, this particular use case. And we don't drop this. We are still mentally immersed in this problem we are trying to solve. And then we go to a next threshold. So we go to 1 second, which is a limit of users' flow of users' thoughts to flow through, or things that the user is thinking about stays uninterrupted. So we can notice a delay, but we are still in the same context, and that's kind of a limit how long it should take if we are trying to run it directly from the IDE. If our single task is taking less than a second and we run it because we are building, we can practice TDD, we can run test-driven development, red-green refactor, because we are still in the same train of thoughts. even though we can notice slight delay. And then the next limit is 10 seconds. If things happen more than 10 seconds, we need to get users' attention back, because kind of people keep losing attention on the process that we are having. So if things takes more than 10 seconds, it leads to something like this, that you start to build up a notifications, an audio sign that the build has finished and your tests are here. So that if we run integration tests and black box tests and so on and so forth, it takes usually even a few minutes. And we have to get this reminder. Otherwise, we'll start doing other stuff, like making coffee. Yes, back to tests. So now we know that this test should be fast, like blazing fast. And we get to next level of our microservice archetype. So we have unit test covered, that's obvious. We have the basic integration, so we know that our application talks nicely with the framework. And now we would like to check how our other dependencies are working. Is my app taking the HTTP calls as expected? Can it talk to other services? And how we can do it. So let's think about it this way. So if we are about to call some external service, like here, we'll do an HTTP call. We are using a WireMock server and against the same JSON test. So we are trying to get from the concept of just working within the unit, within a small framework, and we are getting outside of our application to HTTP. If we take WireMock or any other HTTP technology, we have a server running underneath, and this is being stopped on the server side. This client actually goes out to the internet, well, to this mock service, and makes an HTTP call. It takes time. 600 milliseconds, 800 milliseconds per test. We have to build up a server, an HTTP server. We have to make a call at its I/O. Even though it's localhost, it goes out to the network, and through the loopback interface, it goes somewhere. It takes time. That's the thing. But that gives us really good insight that this call has been actually made. And the response we are getting is actually being parsed and interpreted within our system. So we are safer to go outside and figure out if things are working correctly. Now it's going to be a weird thing in the internet presentation, because the cat I'm having just stayed in the room while I was talking, and now she's trying to get out. So I have to let her out. And now I'm back. That's something that's never going to happen on offline conference, but that's the beauty of an online conference. Yes. Besides this HTTP call, we can try to make. We can think of other things that we can use. We can call out outside, or that we can be called out by somebody else, and we can verify that as well. So we can get to something like contract testing. If we are exposing an API, if we are calling out for some API, we can come up with a different suite of tests where we define that we would like to call this URL with some headers and and we have some expectation about headers and some body. And when our code sends out an event or calls HTTP, then we would like to receive something like this, and that's our expectation. And if we use things like, for example, packed consumers and packed contract testing, that's again something that helps us validate our assumptions. Again, yes, that takes time, but that's kind of how our app talks with the outside world. And the last final example, then we can start embedding stuff into our tasks that we are using within our application. In this particular example, that's just an instance of the Hazelcast cache, but we can do embedded Redis, embedded Kafka. We can do other mock MVC-like things where we actually in our test try to talk with particular instance of our Hazelcast cache so that we will know that once we handle one event in the cache, then we'll get another, we'll get exactly the same event or exactly the same data from another instance of the cache. And why it's important? Because it impacts, for example, serialization. That's a thing within the Hazelcast. It impacts how our data is being sent over the wire, how it's being serialized on Kafka or on Redis. And these are things that at some point we need to test, because the way those services, though the infrastructure is being configured, impacts how our application operates. I call it advanced integration testing. So there's a lot of I/O. We are testing if this I/O integration is correct. Can we save data things to the database? Can we send stuff over the wire? We are still within the same JVM, which makes think reasonably fast and reasonably independent, and we can run it wherever. We can try to validate the API, what we provide, how we consume, and if message serialization is working correctly. The database abstraction is one of the examples. If I'm writing, because people say, well, I've tested my database against H2 embedded database, but this is not exactly the same as MySQL or my production environment. And the mappings, even though if I'm using some object relational mapping, can be different. The behavior of saving, merging objects might be different. At some point, I have to test it against the real database scenario, because how I coded it might impact how it's being processed, and mocks will not show us. The another example is the messaging. If you are using message broker like RabbitMQ, it's fairly flexible on the payload you're sending out. But if you're using something like Amazon SQS on AWC, it's text-oriented, a full stop. And if you start sending binary data, it will just to-string it, and you will get gibberish instead of your JSON payload. So these are things you need to test and verify, not to fail when you do upgrades or you do some modifications in your infrastructure-related code. Great. We can proceed, because now we start thinking of, okay, I've tested unit tests, I had some integration tests, I know how my system talked with HTTP, how it's exposed other HTTP to other clients over HTTP, how it's talking with like Kafka or some embedded caching or not embedded caching. Can we take it further? Can I verify that when I deploy, my service will adhere to expectations and stuff and things that I essentially have to do when I go out to production, whether it's the database I'm having there or monitoring system or whatever. Yeah, we have to drill that down a bit. Because when we go out to production, those things that we start using, usually we call it as infrastructure, but if we look into 12-factor application definition, it's kind of a backing resource. So any service that our app consumes over the network is a part of our own normal operation, and we have to understand whether within our context, within our use case, we are correctly integrated with that. It can be database, writing or reading something from the database. It can be consuming data from queues that's a little bit covered. It's calling out to different services, but it's also, for example, HA. If we are assuming that our infrastructure, our application is running at least 2 instances or more for the high availability, we have to test if it's okay, if it's running correctly, because sometimes apps can be configured to be an exclusive listener for some queues, and then we have a problem. Or some apps can be some of the app's responsibilities is to do some synchronization, and the synchronization just triggers at the same time, and then we have two instances working together, and we need to either introduce some locking or some master slave, or however we design it. But this is something we have to think about. And if we have a chance to test it, like to run two independent Docker containers at the same time and see if the logic is working correctly, that's an additional verification level. So this is what I'm referring to as kind of a white or black box testing. And this is something where Docker made this revolution, and projects like test containers really help us to validate whether we are doing a good job as engineers. So in this example, we are having something which I refer to as a white box test, because what we are trying to do is we are trying to say, hey, this application is a Spring application, and you would like to run this steps within the Spring context. But at the same time, we are trying to get test container telling this application, hey, you will be talking with a Rabbit container and a database container, which is a MySQL. And within this MySQL, you will be using some SQL data to initialize the database. And what we'll be trying to do is we'll try to get to test if our application started, is our application up and running. Once we have an application with a context, with a MySQL container and with a Rabbit container, so the backing services this application expects. Why I refer it as the white box test? Because I still have some insight into how our application is configured. And it's not only through environment variables, as the 12-factor apps evangelize, but it's through some individual or like internal configuration that I can, within the Spring framework, provide. So, is it a good test? Well, I'm testing against the real database and the real RabbitMQ. Is this test fast? Well, not entirely. It will take about probably 8 to 10 seconds to start, depending how fast our container is running on my local machine. Will it give me some confidence? Yes, because that's a real database, and I can make some efforts to make sure that this database is the same, or is at least same configured as the one that we are having on production, which is a very good sign. But at the same time, I can fiddle with the configuration in a way that my app deployed on the production environment will have a different configuration than my test. So there are things that might be broken still, and my test won't figure it out. Let me give you a recent example. Staying in the Java Spring world, if you're upgrading your Spring framework or Spring Boot framework from like 2.4 or to 2.5, or from 2.3 to 2.4, I don't remember exactly the names. There were some significant changes how the authorization and cross-origin resource sharing was organized and configured within the framework. And some configuration parameters changed. So if you wanted to just expose your actuator endpoint to everybody, you have to configure it differently. Then you're doing it now. And if your test configuration didn't have management configuration for the actuator won't even start in your test, and that way you won't even notice that something was off. You will notice once deploying to production. And that's the thing. That's the thing you would like to test as well. And that's something that you cannot get in this particular test case. But we can go further. If we are in the constellation of test containers and running the Docker images together with our application and orchestrating it within our test context, we can get further. What we can try to do is we can define all the services in the Docker Compose together with our service. It's just run everything as a single network. What it gives us is that we have no idea and we have no way to get inside of our application. It'll be just running as if on production. So if we would like to tune something or change something, we have to do it through the official way of configuration params or environment variables. In the same way, we are doing it through values in our Kubernetes deployments. And that's a good sign, because we are sure that we are running exactly the same configuration of the app, regardless whether it's production or whether it's test. So we get an entirely black box test. The downside is time. This takes a while to start up. And if we're just using the test containers annotation, the containers are stopped and restarted every time. So it takes even more time. So we have to think how we organize our tests so that they will start once and all the tests will be independently run or randomly run, but it will be independent of each other. And then still, there's a number of things that we cannot test. And we probably won't be even able to test it locally unless we deploy the stuff we have in production. If you're running Kubernetes, and at the moment, many people are running Kubernetes, things you can't figure out and easily test is like networking. If you run it through the Docker Compose, you have a single network for the whole Docker Compose, which is different if your services are talking to different namespaces in the Kubernetes environment. That may change. If on your Kubernetes environment you are running any type of meshes that fiddle with your HTTP request, that's something again you won't easily achieve in your black box test. But still, testing is not about replicating whatever we have on production. It's about confidence we as developers have in our system. And the code we are delivering is not breaking, is not doing any regression to functionality we've already provided. So within this context of the black box testing, we try to integrate all the layers, all the database queues with our production configuration. And we kind of verify if our system is production ready. We try to test as close as production to that configuration. And that's usually working. Working nicely. We can go further. That's the last final idea, probably, that we can try to look at this black box test purely from the user perspective, like the user-driven approach. And we can try to define these features, this test, in a human-readable way. Whether it's a Cucumber or any other technologies, is just a way for us to express what we are doing, what we are testing. So when any of the stakeholders come over to us and say, hey, how are you testing this one? You can easily say, I have this feature, and this is described in a way that I'm sending some data out data once the user logged in. And the stakeholder says, yes, that's exactly what we need for the compliance. How it's being organized underneath, that's a different story. And it usually maps nicely between the test containers and orchestrating all the stuff and actually running the different scenarios. So what technology you are using and how you combine it all together, it's a different story to that. You have your test organized in different sets so that you know what we are testing and when, and you can easily run things independently, usually gaining time. Yes, time. It's kind of a time to sum up. I've been talking a lot about how long it takes to run this stuff and why it's important. And I thought the best thing to understand it is to make a table. So when we are thinking about tasks, we have multiple areas of interest. We're interested in how things are fast, how fast are things running, because it spends our testing budget. And we are interested in how easy we can modify the context within we are testing. So we can easily test different subtleties and different edge cases. And if we can do it easily, we can do more of this kind of tests. If it takes time to modify the context within which we are testing, we usually just run a happy path scenario and that's all. And with this context modification, with this abilities to modify the context, there's another layer of reliability. It's like, how confident am I that these tests are correct? So is it all working nicely? So when we go for unit tests, we can do everything. Everything is blazing fast, but not once, neither twice I've seen unit testing that passed, but they really didn't test anything, or they just false positive. So I don't want to say that these tests are not reliable. They are reliable, but it's very easy to mess with them and to test things that aren't really tested, and to test things in a way that it gives us false confidence that things are working correctly. But on the other hand, we can have a lot of those and test all the edge cases and different scenarios. Then we go to this entry level of integration tasks. I call it with mocks. So we try to mock out the outside world. We lose a bit on speed. We lose a bit on context modification because we are trying to assemble our packages, services in a way that they are running on production. And we still don't have reliability. I've seen tests that people are mocking out the POJOs, the value objects, because they can. So it's kind of an ape with a knife. Sometimes it's, with a great power, and mocks is a great power. It comes with great responsibility. So you have to think, what are you testing and what you're mocking out? The idea is never touch with mocks the code that I'm trying to test it, because it can just give you a false positive. And then we move to integration tasks with containers, with embedded Kafka, with embedded Hazelcast, and whatever embedded technology. We lose on speed. These tasks are getting slower and slower and slower. And if we don't hack around instantiating those things reasonably, we can lose a lot of performance. People just slap a test containers annotation on their code and think, okay, now I'm testing with the MySQL, but then it appears that they have like 20 tests with MySQL, and each and every test starts a database, and each and every start of the database takes 5 seconds. So we have 20 tests that takes a minute, instead of organizing it differently and having a test that's 10 seconds. So when you see somebody who has improved the performance of their testing pipelines like 10 times from 60 seconds to 6 minutes, that's usually when they figure out that certain infrastructure parts are being kept running and kept running and kept running. With containers, as you could have seen, we still have some context modification abilities, but we get a fair level of reliability, of confidence that we've tested stuff in a way that we should have been testing, and it's working in a similar fashion as on production. And last but not least, we're getting to a total black box test. Are they fast? No. Are they reliable? Oh, yes. I'm pretty much testing in a very similar environment that I'll be getting on my production environment. So as you can see, different approaches to testing give you different ideas and confidence that stuff is working correctly. And now it's a matter to choose how much of each we are going to implement, because we don't want to argue that, I don't need this kind of test. You probably need all of those, but under no means you should do all your testing through black boxes, because that will be slow, that will be cumbersome and hard to maintain and implement. But a good balance between these is what I refer a modern testing triangle. Is this all? Well, you can always test on production. And when people say testing on production, they don't mean shipping the untested, unverified code. They mean all this stuff we've already covered is there, is present. But beyond that, we get metrics, we get logs. So we can collect the runtime information from our system to see how things are doing, how things are going. We get traces so that we can see how things operate between different services. And then we can get to like chaos engineering, randomly turning off different services and see how the rest of the system behaves. Or we can do feature toggles where we do implement stuff underneath, constantly delivering it to production, but we don't show it to our customers. And then we can have canary releases, so we can deploy new stuff. And once some smoke tests do pass, we undeploy the old stuff. So even though our testing triangle is fairly efficient, is fairly big and fairly well tested, there are still ways to improve. I like this approach on visibility and observability on production. So that's me. That's how I see the modern testing triangle and the microservices world. And probably it's not only microservices, it can be other services, other architecture as well, where can you really utilize these ideas and effective testing. Thank you very much. I think I've managed in time. That's wonderful.
Absolutely. Thank you so much. Jakub. I very much enjoyed the presentation. I mean,
he's lying. He wasn't paying attention at all.
Let me now have the questions then. So, the pyramid or the triangle, whatever, cannot stand anymore in front of the new paradigms and the new challenges that the clouds are bringing on, actually. So there is a lot of room for, I don't know, novel practices, for novel experiments and so on.
Yeah, I think a lot of depends what you're delivering and what you're doing, because people very often, and you can do it with this presentation as well, people very often get into this rabbit hole of testing and say, like, I will do the TDD. But to do TDD, you need a well-defined requirements. If you're doing experimentation, you don't do TDD, because that will just stop you. You just want to experiment, and when you figure out what you want, you get on to this practice. So if we go for cloud and you have the idea, yes, we need to, I don't know, deploy it on, or use this service from GCP where we've been using AWS for this long. You go out and experiment, you try to figure out how to combine it. And when you have a rough idea how it's working, then you can figure out, what do I need to test to have confidence that it won't break? Or if it starts breaking, I will have an early feedback that it's not working correctly. And then you can say, well, it's not AWC. I don't have local stock to test it with the containers. I need a different thing. So maybe I'll just encapsulate everything that's related to the GCP into a library, and I will be constantly running some tests with my production account, or like production sub-account on the GCP to verify that the APIs are behaving in the way that they are behaving. So you have to find your ways, and just understanding the variety of techniques you're having, that lets you pick up the right tools, because otherwise, you kind of start replicating GCP on your local environment, which might not end well.
Probably not. Yeah.
That's a change of mindsets, because I don't know, years ago, I mean, decade or more, testing in production was a big no-no. You need to test everything until you get there. But now there are some things that can only test in production to make sense.
Oh, yes, that's true. But on the other hand, this because testing on production is something coming from the big, like Facebook, Oracle, Netflix stuff. On the one hand, it depends on the product. If I'll be doing Forex investment, I'll probably rather not test on production because there is a significant financial risk related to that. But on the other hand, if my responsibility is showing at the bottom of the screen suggested videos, Yeah, I probably can do some more experiments, because if I don't show the latest blockbusters, but something different, the worst it can get, people will take screenshots, and I will end up on Twitter in the memes section suggesting, I don't know, German classic movies to American audience. That's the worst it can get, probably. So yeah, I can afford it, but at the same time, if I'm doing some billing and payments, yeah, I'd rather do it differently. So again, as you said, context is the king, and depending where we end up, we can choose one of or more of the methods of that testing that I've just presented.
Right. There's one particular question here, and I think it should be, I mean, it would be brilliant if we could clarify it. So Hazelcast and Kafka.
Well, you don't compare apples and oranges. And I'm a little bit biased because I'm currently working for Hazelcast. Kafka is a message. Well, it's a message broker. It has an ability to stream millions of messages in micro batches to your client, or just consume it. You can consume it. You can dispatch it among multiple consumers. It's fairly effective in utilizing your hardware and delivering many messages to many consumers. That's the primary use case for the Kafka. Whereas Hazelcast, as we define it at the moment, the Hazelcast platform, is something that is coming from the in-memory data grid, so a cache. You can have multiple instances which will replicate the data all around and help you store in-memory data that you could have not physically store on a single machine. So that's kind of a different context. Obviously, Kafka and Hazelcast have some subtleties about using these main concerns. So you can't treat Kafka as storage, because Kafka can have unlimited or unlimited retention period and never delete your data. So that way you can kind of treat it as a store. Whatever you put to Kafka will stay there forever, and you'll just move the offset and reread the data. And at the same time, as you use Hazelcast for caching, you can use it for example, publish, subscribe, or you can use it as more of a kind of a session replication stuff, not necessarily long-term caching, but a short-term caching, near caching. So it's kind of the main use cases. And then there's like a variety of stuff that you've been using. I will never suggest to anybody replace one with another, because like those things cooperate. If you have a lot of data to process, you probably want to do the runtime processing through Kafka. But then you, at some point, you would like to store it in some near cache or some near data, not necessarily persistent per se in the database, but something easily recoverable from memory through something like Hazelcast. And then you can easily combine this stuff together. So there's no much different. You can't compare one to another. It's similar way you can't compare Kafka to RabbitMQ, and you can't compare probably Hazelcast to Redis, even though these are closer to each other. And I hope it answers the question.
Mm-hmm. It's a very useful clarification. So people ask if you could share the presentation.
Yes, I will send it directly. Well, I'll send it right after we are done to
send it to us,
you
and
folks.
then send it to us, and then we
yes,
on our platform.
Exactly. That's how it usually works.
So then it looks like the 2 days Codecamp with the Java thing. It's coming to an end.
Yes, it has been a great honor. I've seen that you had a nice lineup of different speakers. I've managed to tune in to watch some of these. I will probably catch up with the recordings after that, because that's really interesting to see both these lightweight threads thing, which is very internal, and what you had in the beginning of the day-to-day with the observability for the Java world. Very different topics, but on the other hand, kind of letting you understand better what we as engineers are doing. So looking forward for the recording as well.
Yeah, they will be on our YouTube channel in the coming weeks.
Perfect.
Once again, thank you, Jakub.